This question is about the chemistry of aromatic compounds. In Part A, we're told that benzoic acid can be nitrated by concentrated nitric acid in the presence of concentrated sulfuric acid as a catalyst, as shown in equation 17.1. The organic product of this reaction is 3-nitrobenzoic acid. In Part 1, we're asked to outline the mechanism for this nitration of benzoic acid and show how sulfuric acid behaves as a catalyst. This mechanism is known as electrophilic substitution, and the first stage of an electrophilic substitution mechanism is the formation of the electrophile. The electrophile in this case would be formed by sulfuric acid and nitric acid. Our electrophile is nitrogen dioxide but with a positive charge, water, and sulfuric acid but with a hydrogen removed and a negative charge. In the first stage of this mechanism, we need to react our electrophile with benzoic acid. There should be a curly arrow from the benzene ring to the electrophile, and in the intermediate we draw a sort of smiley face to show where the nitrogen group is going to end up. So here's what I call a smiley face. You would get kind of two possible routes and a positive charge in this smiley face. This is because the hydrogen from the benzene gets attracted back into the group and therefore would form 3-nitrobenzoic acid. Alongside a positive hydrogen. This positive hydrogen will react with our sulfuric acid ion to reform sulfuric acid and show that sulfuric acid acts as a catalyst because it's reformed in this mechanism. In this reaction or question, we get a mark for the curly arrow in stage 1 and the formation of the electrophile. We get 2 marks for the correct intermediate and curly arrow and a mark for the reformation of the catalyst, and that will get you 5 marks for this question. Part 2. The chemist carries out the reaction in equation 17.1 using 4.97 grams of benzoic acid. The chemist obtains 3-nitrobenzoic acid as an impure solid. The chemist purifies the solid to obtain 4.85 grams of 3-nitrobenzoic acid. Describe a method to obtain a pure sample of 3-nitrobenzoic acid from the impure solid. Determine the percentage yield and check its purity. For this question, we need to write the stages of purification. There are 4 stages of purification. First, recrystallization. We need to state recrystallization. That's a key word for this question. Secondly, dissolve solid in a minimal amount of hot solvent. The key words here are minimal amount and hot solvent. This is a level response question, so you get marks for detail. Thirdly, the third stage of purification is that you need to cool the solution and filter the solid. In this stage, cool, solution, or cool and filter are our key words to get the marks for this stage of purification. The final stage of purification is that you need to wash with cool solvent. Here, cool solvent is the key word. Then, for percentage yield, we need to work out the number of moles. We do this by using the grams of benzoic acid and 3-nitrobenzoic acid and dividing by their relative formula masses. So, for benzoic acid, 0.0407 moles of benzoic acid, and then for 3-nitrobenzoic acid, we do the same thing, take its mass of 4.85 grams and divide by its relative formula mass of 167 to get 0.0290 moles of 3-nitrobenzoic acid. Then, for percentage yield, we take the moles of 3-nitrobenzoic acid and divide them by the moles of benzoic acid. And then we multiply this by 100 to get percentage of 71.3%. To check a purity, you need to do a melting point test. A melting point test will give you a result, and to check the purity of your result, you can then compare your results to known values which you can simply search on the internet, and that will give you an indication of how pure your sample is. As this is a level response question, you get marks for detail, the correct percentage yield, and checking purity. B. A student investigates the relative ease of nitration of phenol, benzene, and benzoic acid. The student finds that the conditions required for the nitration of each compound are different, as shown in Table 17.1. In Part 1, we're asked to state the trend in the relative ease of nitration of phenol, benzene, and benzoic acid. Because this question is asking us to state the relative ease, we don't need to go into a lot of detail. This question requires us to say that phenol is the least reactive, and that's because it doesn't require a catalyst and is at the lowest temperature, and it's dilute nitric acid that it requires and not concentrated. But then we also need to write that benzoic acid is the most reactive, and that's because it requires a catalyst, has the highest temperature, and concentrated nitric acid is required. So by writing these two statements, we can get this mark for this question. Part 2. Apply your knowledge for bonding in arenes to explain the trend in Part B(I). For phenols, the lone pair on the oxygen is partially donated to the pi ring system. The lone pair on the oxygen comes from its OH group in the phenol. For benzoic acid, the carboxylic acid group is an electron withdrawing group, and that means that it's going to be more reactive. Then we need to link by saying that phenol has a higher electron density, and therefore it's more susceptible to electrophilic attack. We don't need to write electrophilic attack, but that's a good bit of background knowledge that you can carry on using in the exams. To get the marks for this question, we need to say the phenol has a lone pair, which is partially donated in the ring system, that statement, that the carboxylic acid group is electron withdrawing group, and we need to do the link between the phenol having a higher electron density and it being more susceptible to attack, therefore it's less reactive. Part C. A student synthesizes 3-bromophenylamine shown below, starting from nitrobenzene. Part 1. Complete the flowchart showing the structure of the intermediate and the formulae of the reagents for each stage. We're told that the first stage is bromination, therefore one of our reagents must be bromine, but we also need a halogen carrier in order for this reaction to occur. This would form an intermediate, and the intermediate would have the bromine in the third position because a nitro group has a 3,5 directing effect. Therefore, in reduction, we're going to reduce this nitro group, and the reagents we need are tin and concentrated hydrochloric acid. These are reagents that you need to know off by heart. There's a flowchart for OCR exams with all of the reagents and reactions on that you can refer back to and we can go over in future videos. But writing the reagents for the two stages and the correct intermediate, those three components will get you the marks for this question. Part 2. Another student attempts the same synthesis but carries out reduction before bromination. The student was surprised to find that 2 structural isomers of 3-bromophenylamine had been formed instead of the desired product. Explain this result and suggest the structures of the two isomers that formed. As I said before, a nitro group has a 3,5 directing effect, but if you carry out reduction first, you have an NH2 group, which has a 2,4 directing effect, and therefore the bromines will be in different locations around the benzene ring. So our first structure will have the bromine in the second position around the benzene ring, and our second structure will have bromine in the fourth position around the benzene ring, which are different to our product. For this question, the explanation of saying that NH2 groups have a 2,4 directing effect gets you the first mark, and each structure being correct will get you a mark for this question.